In the first learning sequence, we discussed how to make a description of your sample, of your experimental values using non-parametric approach. In this learning sequence, we will first of all find out why actually this approach is called non-parametric, and what is a parametric approach, an alternative approach for describing your sample values. Let's start with defining two statistics, counts and frequencies, which are also quite important for most of the statistical applications. And let me remind you where we stopped last time. So we have a sample of size 10, which are 10 apples collected randomly and independently from the same tree. And then we have sugar content in these apples denoted as X in this case. So X are values, are real measured values. Then you can see that we have ordered these values. So every value has a rank, which shows a position of this value in this non-decreasing sequence. And then we computed the percentages, right? So for example, here, the percentage is 5. It means that we expect 5% of apples to have sugar below 8.9. And that's what we call a percentile, right? So 8.9 is the 5th percentile for our data set, right? And then we can make a percentile plot where we show X values as X-axis, and then we show the percentiles, the percentages, as y-axis. That's what we call the percentile plot. So we can say that we can actually represent our values in two different ways. So the first, it's just as values. So this is pretty straightforward. So values are just, the measured values that we got. But we can also represent them as percentages, right? So we can also represent them as percentiles. So that's the very basic idea that we have learned from the previous learning sequence. And then we realized that values have boundaries, both representations have boundaries. Values are bounded by smallest and largest values, while percentages are bounded by 0 and 1. So we cannot go beyond these two values, right? And then we use this representation for example, computing quantiles. How did we compute quantiles? We find intervals with equal number of values. So the percent of values is the same, for example, 10%, 25%, or 50%, and so on and so forth. And then for each of this interval, which we define in P, right? So we define intervals here in P. Then we computed boundaries of this interval in X. So for every interval, for every given percentage of values, we can compute the smallest and the largest boundary, the left and the right boundary of this interval, right? So for example, if we want to split our values into 4 equal portions, in this case we have 25% of values in each interval, so we split our percentages range, which is between 0 and 1, into 4 equal intervals, right? So first interval is between 0 and 0.25, then we have between 0.25 and 0.5, then between 0.5 and 0.75, and then finally between 0.75 and 1, right? So we have equal. We split the p-axis, the percentage axis, into 4 equal portions. And then for every boundary, we compute the interval in x, right? So for example, here, the value we computed, it's 9.6, based on the, in this case, we have this value in our table, right? So it's a value number 3, 9.6, this one. So this is our boundary for 25% of the smallest values. Right, then we find the median as just a middle point here, right? So this is the median. And that gives you the boundary for another 25% values. And then we have also the boundary here, 25, and then also 25 here, right? So this is the basic idea. We split the percentages range into equal portions, in this case, 4 equal portions. And then for every boundary of this percentage range, we find the corresponding boundary in the x, in the values range. Now, we can, of course, do it for any number of intervals. For example, we can split our percentage range into 10 equal intervals. So in this case, we have 10% in each. And this splits these quantiles that corresponds to 10% intervals. They are called deciles. And then we can compute the boundaries. And you can see that, for example, here, the intervals are equal. But here, the size of the interval is not equal, of course, right? So, and so on and so forth. So in general, we can kind of summarize this as follows. First of all, we set the number of values, for example, 10% of smallest values. So we set it. And then by setting this, we compute the intervals, the boundaries that correspond to this set, right? So we set something in percentage, and then we compute something in values representation. Now, what if we swap these two steps? What if we set boundaries in values range and compute corresponding boundaries in the percentage range? So let's try to do that. Let's say we would like to find, for example, to set interval values. So we would like to find how many values we have between 9.5 and 10 grams of sugar, right? So how many apples have sugar content between 9.5 and 10 grams. So in this case, we need to set the interval. So we already set it. You can see it also as a red area here. And then we count. We simply count how many values lie within this interval. So in this case, if we count this, we will find out that we have 4 values. And 4 values corresponds to 40%, right? It lies between the 20th and the 60th percentile. So in this case, we compute a frequency. So we compute how many values lie within this defined interval, where the interval is defined in the values range. Okay. So we simply swap these two steps. So for the quantiles, we set the intervals in the percentage range and compute intervals in the values range. Now we do the other way around. We set interval in the values range and compute the percentages. We compute the boundaries in the percentage range, right? So this is just a very simple operation. So this is just to illustrate it again. So when we compute quantiles, we set interval, and then we compute boundaries that correspond to this interval in the values range. So the interval we set, it's in the percentage range. And when we compute frequencies, we do the other way around. We set boundaries in the x, in the values range, and then we compute corresponding boundaries in the percentage range. Now, in the next video, we will learn how to use this approach, the frequencies calculations, to obtain additional information about the distribution of your data.